Newton's Three Laws and Beyond by Manmeet Gill. Has the question of Newton's laws ever entered your head? What they are and how they came to be? The truth is that the Newton's laws are in fact one of the most interesting topics I have studied because of the way they make so much logical sense. Let's start off with Newton's first law. But before we do, why don't we go over a few of the words and definitions we might need to know before starting. The words that are involved in this law are inertia, mass, balanced forces, unbalanced forces, and net force. Quite a lot of words, aren't they? Don't worry, by the end of this lesson, you will be an expert. What is the relationship between inertia and mass? Inertia is the resistance an object has to change its states of motion. The mass is solely dependent upon the inertia of an object. Let's use an example of a cart and potatoes to show the interaction between the two. If I try to move the cart when it had only one potato in it, it would be less resistant to move because there isn't that much inertia on the object, and the mass is much less. On the other hand, if I try to move a cart with potatoes filled to the top, it would have a lot more mass, which would result in a greater resistance or inertia for the cart to move. Balanced forces are two forces acting in opposite directions to an object and equal in size. Anytime a balanced force occurs, the object will stay in the same place or continue moving at the same speed in the same direction. Unbalanced forces are the forces that cause a change in motion of an object. The net force is the vector sum of all the forces that act upon an object. On the right, it shows two people pushing on a box with the same force, so this means the box isn't moving. This shows a balanced force. On the left, there is a picture of a person moving a box, with the person being the unbalanced force acting on the box. Now that we know all the terms, let's talk about Newton's first law of motion, also known as the law of inertia. It states that an object at rest and an object in motion will stay in motion with the same speed in the same direction unless acted upon by an unbalanced force. Let's use an example. In the picture, it shows a box at rest, and afterward, a person starts pushing the box. So the box, when it is at rest, is balanced because there are no forces acting on it. But when she starts moving the box, she acts as the unbalanced force acting, which causes the box to move. Okay, we are finally done with Newton's first law. Whew. Let's move on to Newton's second law by first discussing the terms we need to know. What is free fall? Free fall is when objects will fall at the same rate without notice to the mass of the actual object. An example of a place with free fall or no air resistance is space. So now, if I were to throw a feather and a rock at the same time, which one would reach the ground first? Trick question. They will both land at the same time because an object in free fall falls at the same rate. Acceleration is the rate at which velocity changes. Force is the push or pull that is exerted on an object. Mass is the amount of matter in an object. Newton's second law states that the acceleration of an object as produced by the net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. But that's kind of hard to understand. So an easier way to say this is that acceleration is produced when a force acts on a mass. The greater the mass, the greater the amount of force needed to accelerate the object. For example, an object that has a greater mass will have to be pushed or pulled by a greater force to go at the same speed at which an object with a smaller mass is going. Let's move on to Newton's third law of motion. Newton's third law of motion states that for every action there is an equal and opposite reaction. Now what does that mean? It means that for every interaction there is a pair of forces acting on the two interacting objects. Let's take an example of a fish swimming in the water. The fish pushes its fin against the water, but that's not the only thing that has to be done in order to make the fish move. To actually move the fish, the water has to propel the fish forward. You might be wondering that I hadn't even explained what action and reaction pairs are. Well, to do this, you have to identify the two interacting objects and describe which one is pushing on whom. That's it. Hopefully this lesson may make it easier for you to understand Newton's three laws and how important they are in our everyday life.